Hi, I am Tzu-Yun from National Taiwan University. I am going to share our works, ElastiLinks, force feedback between VR controllers with dynamic points of application or force. Handheld controllers are the common devices in VR. Force feedback is commonly used to enhance realism. Force feedback is not only on, but also between controllers, like playing a shooting game using a ball and a slingshot. However, to achieve realistic force feedback, not only realistic force types, but also proper points of application of force are essential. A point of application of force, or also called a PAF, is where the resultant force is applied to. As we can see the red point in the figure, when pulling a ball, users perceive resistive force without torque, since the positions of the PAF and the hand are almost the same. However, when pulling a slingshot, users perceive torque of resistive force since the PAF is above the hand on the controller. Therefore, a dynamic PAF on each controller is required for proper PAFs between controllers. Previous works majorly focus on various force feedback on a controller instead of between controllers. For force feedback between controllers, Haptics propose 3 mechanical brakes on their 3 links, respectively, to render variable shapes and stiffness feedback. However, the PAFs are fixed. Some methods leverage the property of dynamic PAFs by moving weight to generate weight and shape-changing illusion in VR. However, how force feedback with dynamic PAFs between controllers affects users' VR experience still waits to be explored. ElastiLinks consist of 2 controllers, tracks, connectors, and force links. Each controller rotates a track and moves a connector, where the links connect to the controller on the track. Therefore, the connector becomes a dynamic PAF and is able to provide different torque to the controller and the hand. The force feedback between the controllers is generated by force links. Furthermore, ElastiLinks provide 2 common types of force feedback, resistive force and impact. Based on our previous works, Elastic VR and Elastic Impact, on the 2 links respectively between the controllers. With the 2 types of force feedback and 2 dynamic PAFs, ElastiLinks achieve realistic and versatile force feedback between controllers in VR. Here we can see how ElastiLinks work. The connectors with rotation and offset movement achieve dynamic PAFs. The offset is perpendicular to the rotation plane. Then we performed 3 user studies to evaluate our device, ElastiLinks. We first conducted a perception study to understand users' resistive force and impact level distinguishability between controllers, which is for proper PAF study design. 2 VR scenes were built for 2 force feedback respectively. By adjusting the width of the elastic band between the controllers and the size of the ball hitting the controllers in VR, the participants needed to match the visual feedback and the perceived force feedback best. The wider that the elastic band is, the stronger is the resistive force. The larger the ball is, the stronger is the impact. The results show that 3 levels are distinguishable for both force feedback. We then performed another perception study to observe users' distinguishability of PF, rotation, and offset differences for resistive force and impact respectively, which also proves the necessity of requiring dynamic PFs. This study design was similar to the previously conducted force perception study. The participants adjusted the PF position instead of the force levels in the visual feedback in this study. For rotation, we observed that 2 PFs with the same rotation angle from the initial point, but in the opposite direction was easily confused. Therefore, we computed the absolute values of the rotation data to remove the direction from the consideration for further analysis. The results show that the participants could distinguish the rotation of the PF stimuli, but not the torque direction. For offset, 3 offset stimuli are distinguishable for both feedback. Here are the results of the study. Interestingly, we observed that resistive force with a longer application time than impact has better PF distinguishability. Finally, we performed a VR experience study with 3 applications to observe how dynamic PFs affect users in VR and verify whether the force feedback with dynamic PFs from ElastiLinks enhances the VR experience. Different PFs and force levels for resistive force and impact were provided in survival shooter games with binomial interaction, fighting games with 1 controller grounded on body, and fishing game with 1 controller grounded in environment. In first application, survival shooter game, the weapons were provided are 2 balls, 2 slingshots, rifle, and launcher. Participants use these weapons to prevent zombies from approaching. The force feedback of balls and slingshot are resistive force. For the rifle and launcher, the feedback are impact. In second application, fighting game, we explored how ElastiLinks used for the interaction, grounded on body. 1 controller was fixed on the arm, and the other was held by the dominant hand. The weapons were provided are knife with reverse grip, knuckle, and claw. Participants needed to attack approaching mummies by these weapons. All force feedback in this application are impact. In final application, fishing game, we anchored 1 controller on the decks to show how ElastiLinks were used for the interaction, grounded in environment. The participants held the other controller as a fishing rod in VR. The grounded controller rotated the track back and forth between -45 degrees and 45 degrees to simulate the fish moving against the participants. 3 feedback methods was compared in this study, including vibration, fixed PFs, and ElastiLinks. Vibration from the Vive controllers was regarded as the baseline for the comparisons. Fixed PF method was implemented by ElastiLinks devices with multi-level resistive force and impact, but with fixed PF. The results show that ElastiLinks has better realism, enjoyment, and distinguishability. In conclusion, this paper provides force feedback between controllers with dynamic PAF, explores users' resistive and impact force level perception between controllers, explores users' distinguishability of offset and rotation differences of PAF, and proves that force feedback with dynamic PAF from ElastiLinks enhances VR realism. Thank you for your attention.